Welcome to the project demonstration of AI powered solar energy management system. So in this project, the main application here, we are going to continuously monitor the renewable source of solar panel voltage, current and temperature, humidity along with the light intensity with the sensors, and that was input to the microcontroller Arduino Uno we are using for analog to serial conversion purpose. As the main processing unit in our project is Raspberry Pi. So this Raspberry Pi will taking care of input of this sensors data, and that will be converted analog to serial with the help of this Arduino Uno board. And we are going to continuously measure the battery voltage with the sensors, and the same voltage will be monitored by the Raspberry Pi, and it will control the relay whenever the battery voltage is low. So the main purpose is like continuously monitoring the solar panel status with the sensors. The sensors we are using is DHT11 to get the humidity and temperature, light sensor, this is a LDR, and this is the voltage sensor of the solar panel, and this is the voltage sensor of the battery pack. And the next, this is electromagnetic relay to control the voltages to the battery pack whenever the battery voltage is low. And this is the charging circuit, and this is used to charge the battery pack with the help of solar panel as well as from the grid also. So this is not of the part of the project, directly the total system getting driven by the battery pack along with the solar panel. But in case when there is no sunlight, then we need to charge a battery pack with the help of this transformer. And once the battery is charged, we can utilize the power to the grid directly to the 12 volts AC output with the help of this inverting circuit. So it has two stages. One is the inverter and there is a step up transformer. So after these two stages, we will get 230 volts AC outputs. And the so-called data continuously monitored by the LCD by using the Raspberry Pi we are using model. And so the data is continuously uploaded to the ThinkSpeak, so which consists of temperature and humidity, and next light intensity, solar voltage, solar currents, battery voltage, battery currents, and finally efficiency. So the main part of the project is outcome with help of Raspberry Pi, the AI utilized to get this efficiency. So whenever we are getting more input from this light sensor, means when the sunlight is more, it will provide us the 100% of sunlight availability. At the same time, we should get the more voltage from the solar panel. So if the sunlight is more but the solar panel voltage is less, then it will affect our efficiency that will be getting calculated by our AI, and that input is to the Raspberry Pi with help of the voltage sensor, which is providing the solar panel voltage, and light sensor, which will provide the light intensity. So based on these two inputs along with the battery voltage, the system will calculate the efficiency of our solar panel, and that will be plotted on the ThinkSpeak and displayed on the 16:2 LCD screen. So the previous data which we have received while we testing of the project, just when you click on the respective data dots, then we can see the battery currents along with date and time. So this is the field 7. So like that, every field with the respective parameter battery voltage. Just when you click on that, we can see the battery voltage here. Same thing for the remaining solar current, solar voltage, humidity and temperature. So we can get this data to be downloaded as a backup purpose, and also we can erase the data to get the fresh data for the presentation. So before erasing that, you need to download the data. So go to data import exports. Then download the data. So once downloaded, the data will be open in Excel sheet, as it will consist of date and time and number of samples till now collected along with the fields. As we discussed, the field 1 is temperature, humidity, like that. So here see the date and time, first column, and the second column is number of samples. Till now we have collected 45 entries, and remaining fields are as respected present on the ThinkSpeak cloud platform. So after we took the backup, now we can erase the data. So to erase the data, go to channel settings. So after erasing only, we can get the fresh live data on the presentation, the private view. Right, clear the data. Channel got cleared. Now go to private view. So there we can see the old data got erased, totally empty. Now before demonstration, first step is we should keep the battery under full charge either from the solar panel or transformer. So let us show you the basically charging with the transformer. Just we need to connect the transformer at this T/S slot. After make the connection, just provide the power supply to this transformer. So the transformer will step down the 230 volts AC to 12 volts of AC, and here this rectification and filtration, there we can see the 4 diodes. Purpose is rectifier to convert the AC to pulsating DC, and the next this filter will remove the pulses, and these 2 diodes will act as a unidirectional current flow. Whenever the battery is fully charged, it will these 2 diodes will block the current flow from the battery to the transformer. So that's a protection purpose, and this LED indication along with the current limiting resistor. So here when we provide the AC input from the transformer, these 4 diodes will act as a AC to pulsating DC converter. But when we are demonstrating the main project, we need to disconnect the transformer and connect the 2 pin at this T by S slots. So it's a solar panel and one more for the voltage sensor. So now these 4 diodes will act as a polarity corrector. When we provide in the AC inputs, they are acting as a rectifier, convert AC to pulsating DC. When we connect the DC inputs, these will act as a polarity corrector. Means if we connect the solar panel in reverse polarity direction base, then that will be rectified with the help of these 4 diodes. We will continuously get the DC. So the DC will be given as input to the battery pack through this relay here. Okay. So just while we demonstrating, you can disconnect this, as this is directly connected to the charging circuit for charging the battery pack. So when we are demonstrating the main project, you need to disconnect this from the B slots, as the relay will get the power supply from the charging circuit to the battery pack. So now next step is we need to on the hotspot in your phone. So for that, configure the hotspot name to project 695H. Right. So configure the hotspot name to project 695H without any space, without any capital letter. Password should be 129 and band should be 2.4 gigahertz. After configure these 3 settings successfully done on the hotspot along with data, now we can on the power supply to the kit. So it will take around 20 to 30 seconds of duration to log into the operating system. So in this Raspberry Pi, we can see this is the memory card, which will consist of Raspbian OS. Once we on the power supply to this, it will take time to boot in the OS. On successfully boot in, a welcome message displayed on the LCD screen, and we can see the one device connected. You can see the Raspberry Pi is connected. Now we can go to the ThinkSpeak and wait till the welcome message come to the picture, and there we can get the continuous data of voltages and current parameters of our project. Right, so welcome message displayed on the LCD and it's connecting to internet. So as we discussed, we should on the hotspot along with the data. Now it's internet connected. Now it is getting the data of temperature. In the first screen we'll get the temperature, humidity and light intensity along with solar voltage. And the next screen we'll get solar current. So SI nothing but solar current, battery voltage and battery current, and efficiency 0% as there is no voltage from this solar panel. So for getting the more efficiency, that we need to place the solar panel under the sunlight along with this light sensor. So parallelly it will be compared and the efficiency will be calculated on this LCD. And coming to the ThinkSpeak, so right, we start getting the data into this. If we click on that, as we discussed, give the date and time and along with the data. So humidity, light intensity and solar voltage, solar current, and field 6 is the battery voltage and battery current, and field 8 is the final efficiency. Right. So just we can change the battery voltage also, and humidity, just to below the air on this humidity sensor we can change the humidity. Right, so you can see the humidity got increased. The same will be effect on this one. So to get the efficiency properly, we should get the more lighting on the solar panel. Lost it on it. Right, so as we are getting the solar panel voltage, and now just place the lighting on that, turn on light. So we can see the light intensity on the charging circuit also. and this is the inverter directly. As you can see, the efficiency is increasing.